Alright, today we're going to work on sine, cosine, and tangent a little bit more. Specifically, we're going to look at their opposites. Everything in life in the world has opposites. Addition and subtraction are opposites. Multiplication and division are opposites. You have an amazing math teacher. There are some not so amazing math teachers out there. So just like that, sine has an opposite. And it is sine to the power of -1. We call this the arc sine, or the inverse sine. We write it as sine to the power of -1. Cosine also has an opposite, and we write it as cosine to the power of -1. And it is called the arc cosine, or the inverse cosine. I usually call these the arc sine and arc cosine. And tangent also has an opposite, same way. Tangent to the power of -1 is how you write it, and you call it the arctangent or the inverse tangent. So we're going to use these three opposites today to solve some problems. First problem we have is a basketball hoop is 15 feet tall, and I missed here, it is 15 feet away from the free throw line. What is the angle of elevation from the free throw line to the hoop? So it always helps us to draw a little picture. My pictures aren't great, but here we have a basketball goal, and maybe the free throw line is out here somewhere. All right. So with this, we can put in some dimensions. We have the height of the basketball goal, right here, is 10 feet. And it is 15 feet away from the free throw line. We have an angle of elevation that we're looking for from the free throw line right up to the basket. So this is going to make a right triangle, and I'll call my angle X because we don't know what it is. We're trying to figure it out. All right? And so, of course, we're going to use SOHCAHTOA to help us out in this problem. SOHCAHTOA. So we're using this angle X. So we need to first label our sides. The triangle. So we have the hypotenuse. Hypotenuse is always the easiest to identify. Our hypotenuse is right here, and we don't have any information about it. So we're probably not going to use that in our problem. Then we have the opposite side. Opposite is opposite the angle we're looking at. So if this angle X is the one we're using, the opposite side is going to be here at 10. And then the last one is the adjacent side, or the side touching the angle. So we need to make an equation. And we're going to use in our equation opposite and adjacent. So if we look up here at SOHCAHTOA, we need to figure out which one uses opposite and adjacent. And TOA here uses opposite and adjacent, O and A. So we can make an equation. The tangent of our angle, in this case we don't know what it is, so we'll put X, is equal to the opposite over the adjacent. In this case, the opposite side is 10 and the adjacent side is 15. Now this looks a little different from the problems we were working on before, because our variable is right here. And we want to get it by itself always. So we have this tangent that we have to get rid of. So the way we get rid of that is we take the arctangent of both sides. So I'll take the arctangent of the left side, and I'll take the arctangent of the right side, and on the left side, we should find that this cancels out. Tangent and tangent, arctangent and tangent cancel out. They're opposites, as we looked at earlier. So on the left side, we have x is equal to the arctangent of 10 over 15. So to find the arctangent of 10 over 15, we're going to use our calculators just the way we would find the tangent of 10 over 15. So if I bring my calculator up here, arctangent we can find in the same place as we find the tangent. So here's a tangent button, and located right beneath it is tangent -1. That's the arctangent. So find the arctangent of 10 divided by 15, and we get the arctangent of 2 over 3. Our calculator simplifies that for us. But we want a real answer. We want a decimal answer. So to do that, we hit Control Enter, and we get 33.7. So x here is equal to 33.7, that angle. We always want to look at our answer and think about it for a second if that makes sense. Okay, if I'm sending a free throw line going up as an angle of 33.7 degrees, sure, I'll buy that. Alright, the next problem we're going to look at is here. It says you want to build a ramp to jump off with your rollerblades that is 1 meter tall with a face of 4 meters. What angles should you use to build the ramp? Alright, when I was a kid, I used to rollerblade a lot and jump off a lot of ramps. I was pretty good at making them. So let's draw this ramp. We have a ramp. It's going to make a right angle. And it says it is 1 meter tall. And the face of it is 4 meters. We want to know what angle we should use to build the ramp. So it doesn't say what angle we should use. I'm guessing this one here. We'll call it X. We can find both just for the fun of it, though. It'll be easy. We have a triangle here. We're going to use our SOHCAHTOA to find out our missing angle. So first we need a label. The hypotenuse is always the easiest, so this 4 meters here is going to be the hypotenuse. So longest side, the side opposite the right angle. And this side over here is the side opposite the angle we're looking at. So opposite, which would make this side the adjacent. We don't have any information for the adjacent, so we're probably not going to use it in this problem. So if you look at SOHCAHTOA, we can see we're going to use opposite and hypotenuse. So opposite and hypotenuse, O for opposite, H for hypotenuse. We're going to use, our SOH. So that stands for the sine of the angle. In this case, we don't know what the angle is equal to the opposite side over the hypotenuse. So 1 over 4. Now, our goal always is to get variable by itself. So we want to get this x by itself, and we have a sign next to it. So we need to get rid of that sign. We know that the opposite of sine is the arc sine. So if I take the arc sine of both sides, I'll take the arc sine of the left side, and I'll take the arc sine of the right side, we'll find that arc sine and sine cancel out, so we just get x equals the sine, the arc sine of 1 over 4. So we can put that into our calculators to figure out the exact answer. Arc sine of 1 divided by 4. And if we hit Control Enter, we get 14.5. So x is equal to 14.5 degrees. So our angle here we need to make to build our ramp is 14.5 degrees. If I want to know what our other angle needs to be for our triangle, the one right here, you guys should remember that all 3 angles have to equal to 180 degrees. So we can figure that out really easily by taking 180 and subtracting 90 from it, and also subtracting 14.5 to come up with the rest of 180, and this angle should equal 75.5 degrees. That is all today. Thanks for listening.